In this video, we're going to use some of the concepts that we discussed in the first video to answer the following questions. So here we're given a circuit with 3 resistors, and we have 3 ammeter readings and 2 voltmeters. The first thing that you need to realize is that this 12V is the total voltage, because this V1 is measuring the total voltage in the battery. So the battery will measure all the voltage which is required in the whole circuit. So this is like your total voltage, okay? And then the first question says calculate the total resistance of the circuit. To calculate the total resistance, you check how many resistors that you have and which ones are in series, which ones are in parallel. Then you apply the principles. So let's check. So in order to determine if it's series or parallel, I said you must move your current from positive to negative and see wherever current has 2 pathways or more than one way to go, then that is a parallel combination. But if there is only one path, that is a series combination. And then you already know that series combination, we say R total will be, okay, R series is R1 plus R2 plus R3, and it goes on like that. And then in parallel, you already know RP is 1 over R1 plus 1 over R2 all to the power -1. Then we can move on from there, okay? So let's check this question. It says the total resistance. So I'm going to move my current from the positive to the negative. So the bigger one here is positive, then our negative is this side. It means current is going to move this way, then it's going to move that way. But when it gets here, current will either go up or go down. That is 2 pathways. It means this is a parallel combination. So we have a parallel combination there, and then current will move on like that. And then when it gets to this resistor, this is the only way that it can go. It can't split when it gets there. You can't say it's gonna split this way. This is a voltmeter. It only measures voltage, and it has a very high resistance. Therefore, current can't go through there. So current cannot go through the voltmeter, so you can't split it there. It can only go that way. It means here we have a series combination, okay? Then we can now calculate our total resistance. We're gonna say 11.1. Our total resistance will be this resistance on parallel, so it will be R parallel plus R series, because we have a combination which is in parallel, and there we have a component which is in series. So the total, we just add them up. But we know that in parallel we say what? 1 over R1 plus 1 over R2 all to the power -1 plus R series is just R1 plus R2. So there in series we only have one resistor, so we just write that R1 or just R4 ohm, okay? Then we're gonna move on and say for the parallel one, it's gonna be 1 over 6, that's 6, plus 1 over 3 all to the power -1, then plus the 4 ohm for the R series. So let's check what we get there for the parallel one. 1 divided by 6 plus 1 divided by 3, 1 that is 2 ohm plus 4 ohm. That is a total of 6 ohm. This is the total resistance of the circuit. All right. So now 11.1.2. 11.1.2. They say calculate the reading on V2. Let's check V2. There is V2. So we want to find out the reading on V2. Let's check. This voltmeter is only measuring the voltage through here in this resistor. So it means they want us to calculate the voltage through the 4 ohm resistor. So we check the formula for voltage. V equals to IR. So we write it down. V You can say V2 is equals to IR2. Or can you just say RR? It's fine. Just V is equals to IR. Okay. But let's check, do we have resistance? We want to calculate voltage, right? Do we have resistance? We do have the resistance at 4 ohm, that is 4 ohm. So we have the resistance, but do we have the current? There is no current that is given there at 4 ohm. So what you do is apply the principles that we discussed in the last video and check if you can relate it to this point. Okay? So what you're gonna do is what did I do now? Okay. So let's check where can we calculate this current that we want to use here in order to get the voltage in V2. Where can we calculate it so that we can relate it into the 4 ohm resistor? Okay. So we know that current, we are looking for current now because we want to use it, right? So we're gonna say current, we know the formula for current is the formula for current is I equals to V over R. And then we check throughout the whole circuit in which point do we have voltage and resistance. So you just check the circuit and check which point do you have the values that you need in order to calculate the current. Okay, I'm going to move around the circuit and check at which point do I have these things that I must use right now. So now first add this 4 ohm. At this 4 ohm I only have resistance, I don't have voltage, I don't have current. Then I come to the parallel circuit. The parallel circuit I only have the resistances, but I don't know the current too, so I pass there. Okay, when I come to this point, they gave me the current. They say current is 2 amperes. So they already gave me the current. I don't need to calculate it. So I must take that current and relate it to 4 ohm. Okay. So let's check the current that is given. It's in ammeter 1. So the current in ammeter 1 is 2 amperes. That is just given, right? So let's check how can we relate these 2 points in this circuit. This point here where I have the current and this point here where I have the 4 ohm resistor, because I want to calculate the voltage at this point. In order to calculate the voltage at this point, I need the current because my formula says I must use the current. So let's check the relationship between these 2 points. Just pause the video and check if you can reason according to the principles that I explained in the last video. Okay, now we can continue. What I can say is, if I check this point, the current which is here is going to move like this, right? Then it splits there, and it goes this way, that way, that way, that way, and then at this point, the current, this coming from this side and that side, they are combining to form one thing, which is a total of what we began with there. So the current at this point and the current at that point is equal, right? Then the current will keep going up like that, which means the current which is there and there passing through there, the 4 ohm resistor, they are equal. So in simple terms, you can simply say the current at A1, is equal to the current at 4 ohm, because these two are in series. We said it in the last video that series component has the same current. So you can simply say from that point, okay, the current at A1 is equals to the current at 4 ohm resistor. So it means you can simply take that current and substitute it there. So now it means V2 is equals to I, which is 2A. We're going to use this 2A because we said they're the same. And then the R is the resistance at 4 ohm. So you just put 4 ohm. You multiply these two, and then you get 6 volts. Okay, so that's how you calculate. If you're asked to calculate something at a certain point and you don't have all the values that you're required to substitute in your formula, just go and calculate it somewhere else and check if you can be able to relate the two components. Okay, for example, let me check something here. If they gave me that the current at A2, the current at A2, yes, it's 3. If they said it's 3 amperes, and then they say calculate the voltage, let's say here they want you to calculate the voltage that it is being measured here. They want you to calculate the voltage here. So let's check. I will say that this voltage is measuring for this resistor, right? So if it's measuring for that resistor, I want voltage. Voltage is equal to IR. But do I have the current at this point? No, the current at this point is not given, right? But the resistance is given. So I must go and calculate current somewhere else and relate it to this point, or calculate voltage somewhere else and relate it to that point. So what I was going to do is I was going to calculate the voltage at this point, because to calculate voltage at this point, I'm given the resistance, and I'm also given the current. So I was simply going to say V equals to IR, then I multiply the current. 3 multiplied by 6, I get 18. So I check if I can relate this value to the voltage which is here. I was simply going to say the voltage at this point is equal to the voltage at this point, because these two things are in parallel. Do you see that? So if you ask to calculate something and you can't because a certain value is missing, just calculate it somewhere else where you have enough data or sufficient data to calculate, and then relate it to the other part that you need to calculate for. Alright, let's quickly check the last question. The reading on V2. We have calculated it. And the reading on A2. Alright, let's check A2. To calculate the reading at A2, we need voltage, because when they say A2, that is current, because the ammeter measures current. Current is equal to V over R. Do we have the voltage? Let's check around. Where do we have voltage that we can relate to this point? I have this voltage here. This voltage is in parallel, so the battery is in parallel with these components here. So if they're in parallel, they have the same voltage. So you simply take the voltage at the battery, 12 over R, which is 6. Then you find your value, which is 2A, right? Then the amount of charge that flows through the ammeter, that is very simple. The formula that involves charge is this one. So 11.1.4. So charge will be equals to I delta T. So you just take the value for current they gave you at A1. The current is 2. The time is given in seconds, 120. And then you just multiply it. Then you find your answer. That is 120. Alright. So how will the reading on the ammeter A1 be different if the 6 ohm resistor is removed? Good. Let's check what was going to happen. So I'm simply gonna erase this. You can pause the video if you want to write that down. Then you write it down. I just want to make this clear so that we analyze the circuit again. So let's check if we remove this resistor. If I remove this resistor, then I'm left with a circuit which is like that. And when I get here, I only have one resistor, and that resistor is now in series with this resistor. So I remove a parallel component, I'm left with a series component. What will happen to the reading in the ammeter? If I remove a parallel component, I'm going to be left with a series component which has very high resistance. Therefore, I will have less reading in the ammeter. Do you understand? So if you remove this, you are left with a series component. Series component, there is high resistance. I've explained it in the last video. There is high resistance, therefore it will be hard for current to pass through. Therefore, it will be less reading in the ammeter. That's how it's supposed to go about it. All right.